Okay, today you're going to learn about the zero product property. You should have this paper in front of you, and we'll work through some of the problems together. What the zero product property states, you want to write this at the top of your paper. States if A times B equals 0, then I'm sure you can see what should be true. Either A has to be equal to 0 or B has to be 0. Seems pretty simple enough, right? If we have a product that's equal to 0, either that number equals 0 or that number. Well, why this applies to these problems is we do have a product. It just looks a little different. It's in the factored form. So notice if we have something factored, this is a product, it's equal to 0. Either this factor has to equal 0 or this factor. So we can solve for x by stating 2x minus 4 equals 0 or x plus 5 equals 0. And you're just going to solve those two equations. Add 4 to both sides. And divide by 2. So one of your solutions is 2. And I can subtract 5. So x equals negative 5. So all that means is this equation has two solutions, and you can quickly check. If I plug in 2 into this equation, I get 2 times 2 minus 4. This becomes 0. 2 plus 5 is 7. It doesn't matter. 0 times 7 is going to give you 0. If I plug in negative 5 here, it creates a 0 right here. Times this factor, it doesn't matter. We're still going to get 0. Okay, so as long as you have 0 on one side and a function or an equation in factored form, you just repeat that process. Okay, so let's look at one like number 3. We have two factors set equal to 0, so one of these, x equals 0, or 4x minus 3 equals 0. Well, here's one of my solutions. The other one can be found by adding 3 and dividing by 4. So the other solution is x equals 3/4. Okay. Now, of course, they're not always going to be nicely factored, like 1 through 9. If we go down to the next section, 10 through 15, it says factor and then solve. So notice we have 0 on one side. We can't use the zero product property until we have a product, so it comes down to factoring, which we spent a lot of time on, so you get more practice. Okay, we're going to do our diamond problem, multiply 1 times negative 12. Middle term is negative 1. The two numbers that add up to negative 1 and multiply to be negative 12 is negative 4 and 3. You can either do your box problem, or if you're comfortable with the shortcut that we learned, this should be x minus 4, x plus 3. And remember, that shortcut only works if we have a 1x squared, which we do. Okay. Now that's set equal to 0. So now either x minus 4 equals 0 or x plus 3 equals 0. Solve each of these equations. So we'll get x equals 4. Subtract 3 on both sides, or x equals negative 3. And again, you could take either or each of these and plug it into the original equation and make sure they work. Okay. So it's all about factoring. What's hard about these is you have to determine how to factor them correctly. So let's look at maybe a different type, say number 14. This is not a diamond box problem. Hopefully we recognize this is a greatest common factor type. So the greatest common factor would be 2x. And we'll be left with 3x plus 4. Now we have it in factored form, 0 on one side. Set each factor equal to 0. And students sometimes forget how to solve this one. Remember, 2 is just being multiplied by x. How do we undo that? Divide by 2. So x equals 0. Solving the second equation, subtract 4. And divide by 3, so x equals negative 4/3. Okay, so hopefully you've copied these down. We'll do some on the back side. They're a little different. Okay, turn that over. All right. So on 16 through 24, the instructions state, find the x-intercepts for each parabola. So, see, yesterday we talked about what parabolas are. X-intercepts you may recall from integrated 1. An x-intercept we always solve by letting y equal 0, and you solve for x. Well, notice this is a parabola. If I set 0 in for y, it's essentially the same thing we just did on the other side. We have to factor this and solve for x. So it comes down to our diamond, multiplies to be 6, adds up to negative 7. The two numbers are negative 6 and negative 1. And that's going to factor to x minus 6, x minus 1. You can do your box or the shortcut on that one. And again, that's equal to 0. So we can set each factor equal to 0 and solve. So x equals 6 and 1. And again, if I'm going too fast over any of these, I'm posting this video on my calendar so you can rewatch this tonight if you're confused by any of these. So the same concept on all of these. Just remember on some they'll have a GCF like number 19. Number 20 has a GCF, you know, so be on the lookouts for that. Let's see. Oh, I didn't finish the problem on this because they were asking us to find the x-intercepts. So remember how to write our answers as a coordinate. That's where it's intersecting the x-axis when y is equal to 0. So the two solutions are 6, 0 and 1, 0. These are x-intercepts, so they have to be a coordinate. So that means if you were to sketch the parabola, 3, 4, 5, 6, it's intersecting at 1 and 6. And you would have a parabola looking like this. So that tells you a lot about how to get a quick sketch for the parabola, and that's why we want to be able to solve for the x-intercepts. Okay, let's look at the difficult ones. I think these are the hard ones, numbers 25 through 30. So solve for x. Note you must get the equation equal to 0 first. So you cannot apply the zero product property until we have 0 on one side. So look at where your x squared term is. You always want this term to be positive. So I'm going to move both of these terms to the left side of the equation. So I'm going to subtract 6x. And I'm going to add 8. So be very careful moving terms to the other side. It's going to switch those signs. So I can rewrite it as x squared minus 6x plus 8 equals 0. So you're just moving those all to one side, and then repeat the process like we did before. Multiplies to be 8, adds up to negative 6. The numbers are negative 4, negative 2. Yes, I can use my shortcut again, just because I have my 1x squared. So we get x minus 4, x minus 2. Two solutions are x equals 4 and negative 2. And they're just asking to solve for x, not the x-intercepts. So we can write our answer like that. Okay. And I'll do one more with you, 28, because that's a tricky one. A lot of students want to move all three of these terms to the left side. But notice if I subtract 2x squared over to the left side, that's going to create a negative x squared. And although you can factor with a negative x squared, I think a lot of students get messed up with the signs. So I always bring these terms to the side where it's going to create a positive x squared. So I'm going to subtract x squared over here, and I'm going to subtract 2x to this side, leaving me 0 on the left side, and x squared, combining my like terms, minus x minus 6. Okay, and that's going to be a lot easier to factor. I think you guys can finish it from here, but I'll help you finish it. Multiplies to be -6, adds up to -1. The two numbers will be -3 and 2. So we get 0 equals x minus 3, x plus 2. Set each factor equal to 0. We get x equals 3 and -2. And again, once you start doing enough of these problems, a lot of students skip this step. I'm not too concerned with you showing this work, but make sure you do know how to solve this correctly. And, you know, show your work as long as you need to until you kind of see those shortcuts. Hopefully this has given you enough to get started. And again, re-watch the video if I lost you anywhere or if you need to watch it again. And good luck, and I will see you tomorrow.